Perfect. Hello, everybody. How's everybody doing? Happy Thursday. Today's Thursday, right? Perfect. Happy Thursday. We're just going to wait about a minute or so, let people join in, and then Amanda and I are going to bring you Kids Discover Online Kitchen Chemistry Part 2. So stay tuned. We're going to get started in about 1 minute or so, okay, guys? See how many people are watching. Should we just go, Amanda?
Yeah, let's do this.
All right. So Stephanie, you want to back up a little bit so we both get in? All right. Stephanie, can you see us both?
I can see you both.
Perfect. Hello. So we are coming to you live from Siouxland Libraries for Kids Discover Online. I'm Jamie.
I'm Amanda. We are at our downtown library as usual, and we are super excited to be here.
Yes.
So what are we doing today?
Today we are doing Kitchen Chemistry
Okay.
Part 2. Yes. So, but before we get started, we're going to show you a couple things, recap.
Yeah.
So on our very first one, we did Wizard's Brew, and we had this really cool shout out from Mia. Mia did some Wizard's Brew at home, so Mia, thank you so much for sending in your picture. We would love to see your guys' experiments. If you do them at home after watching our videos, you can either share them in the comment thread or send them to our Facebook page in a private message, and we can check with your parents to make sure we can put it on our PowerPoints here.
Yeah, that would be great. We love to see our experiments in action at your place too. So let's keep that up, and let's check in to see what the next one is here. Oh, right.
Yes.
Perfect. So if you remember, our first video we did Kitchen Chemistry Part 1. Okay, and so this is our rock candy, but this is our rock candy on day 4.
Okay.
So we're kind of just looking at progress here, and this is the kind of thing that we're hoping to see from you guys. Now, you can see this is growing pretty well, right?
Yeah.
We've got our string, lots of crystals are starting to form in our green color here, and this one, it doesn't actually look like it's going too good, and I think that's for a couple reasons. So if you notice, our crystals are really forming well along the bottom here, and that's because that jar is a little bit textured. Just, you know what I'm saying by textured?
So almost like those little bumps that you might find at the bottom of a jar?
Exactly, right? So our crystals like to grab to those kind of textured surfaces, and our string's a little textured too. I think that's why it's going a bit better here. But this one, we've got some weird curves in our glass. We're also using a stick, and I think maybe that's what's going on in our images there. But moving on.
So day 4, that would have been Tuesday, right?
Yes, Tuesday.
Okay.
We checked in and we posted those in the comments, and we'll continue to do that, post our progress as well. So we're just hoping to build that in our comments, and we are going to check in on our rock candy now here.
Yeah. Show us what we got, Amanda.
All right, so let's take a look. Now, we have several different solutions that we made when you guys were with us. We actually made a couple more. This is our vase, as I had mentioned, and that one just didn't like to grow on the stick, but it did kind of grow just along the top, which is really interesting. And if I pull it out here, you can see I don't have any candy attached, but there's all sorts of strong crystals that have grown up on the top. And I'm just going to set that back in there. Now, this one we did on our string, and if you take a look, it grew really well for us.
Whoa, that one looks awesome.
It turned out really great. Now, if you want, you can lay this out. If you want to put it for a few more days, you can. At about a week, it gets to be, you know, that's kind of your end of your experiments. You can definitely give it a few more days. But if you guys have crystals growing like this, please let us know, because this is awesome. And I'd love to see what color combinations you did. And even we talked about adding some flavors. So maybe you did that at home too.
So Amanda, if I'm ready to pull out my rock crystal, what should I put it on then?
Good call. So it is going to be super sticky, right? Because we had that really saturated solution of sugar and water. And so what we want to do is maybe put it on some wax paper, because whatever it's going to dry on, it is going to stick to. So definitely don't set it on like a paper towel or anything like that. So in this one, I actually haven't removed yet from its solution. So we're going to take a look here. No matter what, you're probably going to have to break a little bit of that stuff on top. So we're going to do that.
It's like cracking into a treasure chest.
Yeah, and you can hear it, right?
Yeah.
Can you hear that stuff?
Yes, I can hear it.
All right, we'll see how this goes. And a lot of times, and it looks, I mean, you can tell at the bottom here that it's probably stuck,
Yeah,
right?
you can see all that growth down there.
You can see the growth down there. This one grew super fast and really well. I'm gonna actually kind of see if I can get it free from there. I can feel it moving, but it's really stuck.
Do you need me to hold the jar?
Yeah, if you want to do that, that'd be great. We'll see if we can get it. Almost. There we go. Oh, goodness.
Whoa.
This was a big one. Look at that. That's so cool, though. Look at, and as I said when we were talking about this the first time, the really great thing about this is that now you can see sugar crystals on like a much bigger level than we get to see them on, you know, in our normal daily life. And they look, if you remember, a lot like the crystals that we looked at with the microscope.
Yes, like
right?
those elongated cubes,
right.
those stretched out cubes.
Our elongated cubes, because that's how sugar crystals like to grow. And crystals and the same chemical structures, they like to stay the same. Experiment. I would recommend, doing this at home and doing it a couple different times. Maybe if you did it with sticks, try it again with strings to make sure that it'll work. And maybe if you weren't able to make it work with sticks, by all means, please share, because our same one did not do so well on this. So, are we ready to get started with our new stuff, though?
Let's do it. What's our first experiment today?
Okay, so we are going to talk about eggs.
Okay.
My hands are very sticky.
I love eggs. Are we going to eat the eggs today?
We have a pretty solid rule here, and I think you know, like, we never eat science.
Okay.
I know it's tempting.
Is there a reason why?
Well, there's several reasons why. First, we're creating an experiment. Second, a lot of times in our program room, we have supplies that have been in our cupboards for a while, or maybe we've used them in different experiments, so we always say don't eat science in that regard. But we just don't really know exactly what we've got, and we want to keep it safe, clean, healthy. So yeah, we're not going to eat these, and especially not going to eat these today, because they would be awful, awful, awful. So
I'm excited.
all right, so what we did, if you remember, we have our jars, and we have an egg inside that jar. If you want to get close, I'm sure you can see it well, and you can see that we've got some of the egg actually coming off already in the jar. So this is a cup of vinegar inside here, and we are going to rinse that off. Now, I'm just going to kind of dump some of this excess vinegar out until I can get to my egg, and then I'm going to rinse it off here. And you can see that is just coming right off. So,
whoa, it's gnarly.
Isn't that cool? Look at how...
Oh, gross.
Yes, it's definitely a gooey sensation, certainly, but you can slowly just kind of rub off that shell. And so do you know what's happening here?
I don't. So vinegar, I do know that vinegar is a weak acid.
Yep. And you know, so you want to think of it as an acidic acid.
Okay.
Right? And our shell is made of sodium carbonate?
Calcium.
Sodium calcium, excuse me. And we are going to the vinegar turns it into, breaks it down.
Yeah, so the vinegar, that acetic acid, is then having a chemical reaction with the calcium in the shell, starting to break the bonds,
right.
And then it allows kind of that egg to break apart and almost dissolve, it looks like.
Right, so calcium.
Yep.
Right, calcium carbonate. That's what's happening here, is that acid is breaking down that, and it's actually releases some of that carbonate. Ooh. Right? Like the carbon dioxide that we've had in different experiments already in here.
Yeah, okay.
So it releases a gas, and you'll notice when you put your egg in there originally, that bubble started to form right away.
So if I show you this one, you can see there's a lot of bubbles on this other egg here where you can see that reaction happening. Absolutely. Those gases are being released in that bubble form.
All right, so now you can see our egg is super, like, malleable. Like, it doesn't seem like an egg at all.
It looks squishy,
rubbery,
not hard.
It's squishy. Certainly, James, if you want to actually get the other egg going here, you can.
Oh, sure.
And what I'm going to show you while you're doing that is how thick and tough this membrane is, right? So when you're talking about the outside of an egg, you have your shell, and then you've got this outside membrane, and it's really cool because if you think about an egg, and we're gonna pull this up here for you. So we've got our shell, and then we've got an outer and an inner membrane, okay? And that shell is actually what we call semi-permeable.
Semi-permeable, what does that mean?
Right, so semi-permeable membrane, that is gonna mean that air and moisture can actually get through, right? So it's not completely closed off, but this membrane past the shell does a really good job of blocking other things like bacteria and dust and whatnot.
Oh, crazy.
So it allows some of that liquid to come in, but it doesn't allow a lot of other stuff. So if you want to take your egg now and you can actually bounce it, which is super cool.
Wow.
I wouldn't recommend bouncing it from super high because it's not indestructible.
Right, your membrane would probably break at some point.
Your membrane will probably break, but I want to show you something really cool. Now, if you have a flashlight at home, if you shine inside there, thank you, Jamie, you're gonna see, we can actually see our yolk and stuff completely intact inside our egg.
Whoa.
Which is really neat. Now, what we're gonna do, thank you.
Yeah.
All right, so also, the other thing I want you to notice, this is the same type of egg. I use them from the same carton. Are we noticing a size difference here?
Ooh, I think so. I think...
If I put it down and you take a look.
Oh yeah, it looks like the one that we put in the vinegar, that the shell kind of was dissolved off of and broken down, it looks a little bigger.
It definitely got bigger.
How did it get bigger?
Doesn't really make sense, right? Like I told you, that shell is semi-permeable. Want to say that with me really quick?
Semi-permeable.
Perfect, because that's kind of a hard word to say. That is, again, letting in some air and some water, some liquid, but it won't allow a lot of other stuff in. And so what it did is it allowed that liquid to get inside.
Crazy.
But there is a limit, and once it gets there, it just kind of holds the rest of it out. Because if it took all that stuff in, it would break.
Yeah.
Right?
Can we drop both eggs at the same time?
Yeah, okay. Well, let's see what happens. Are we going to drop them from a high enough height, or are we going to drop them from, say, about here?
I mean, whatever you're comfortable with.
Okay. So, count it down.
3, 2, 1.
Ooh. Yeah, no, that's what happens when you drop a normal egg. But it's pretty interesting, right? When you see how, thick the membrane is to protect it.
Yeah.
Now let's maybe go from a higher height.
Okay.
Okay. I'm gonna keep probably the same lovely broken egg in my hand, and we're gonna drop it on 3,
2, 1. Oh, they both broke. So eventually there is a breaking point for that membrane.
Right. Like we said, it's not completely indestructible, but you can see how thick that membrane actually is.
Yeah.
You don't really get to notice that when you're cooking an egg like this. You're not really seeing that membrane. That's because it's actually stuck along the shell there.
Crazy.
So what you can do from here, if you want to see that process of taking in the liquid and vinegar a little bit more,
Yeah.
which is called osmosis, by the way.
Osmosis.
Osmosis.
Okay.
You can do this experiment again and dye your food, use food coloring to dye the vinegar in the water, and your egg will actually take up all of that coloring.
So you could have like green eggs?
So you can literally have green eggs. Absolutely. But I wouldn't eat it again.
Okay.
So what do you have for us today?
I love this. This was fun, and I really want to play with that egg now. But over here, I'm gonna do a homemade lava lamp for us.
What?
So, yes. So for our homemade lava lamps, things we're gonna need are just some empty bottles here. I added a little bit of water so far to start us off. I've got some vegetable oil. I've got some food coloring here. And those are kind of our things to get us started. So I also grabbed a funnel. I know I showed you my expert pouring skills in other videos, but I brought a funnel just to be safe. So I'm gonna take some oil here and I'm gonna pour it into our container. Oh, I got excited. I was too busy looking at the bottle. Bit of an overflow there. All right. So what do you see anything as we're pouring in our vinegar? Amanda, are you noticing anything?
Well, so you've got water in there, but it looks like the vinegar's not, like it's just kind of staying on top.
Yeah, so you're right. So we had water to begin with. We added our vinegar, or I'm sorry, our vegetable oil, but it didn't mix. They stayed separate.
Why is that happening?
Oh, I'll tell you. So there's a couple of things that are at play here. So the reason these are not mixing is because it goes down to that molecular level. Okay. About polar and non-polar with the shape of our different molecules. So like things do not want to mix together in this kind of world. And so like we've got miscible and immiscible. So in this sense, our water and our oil, they don't want to mix. Those molecules are like, no way, social distancing, baby. I do not.
It's just no.
Give me my 6-foot bubble.
Okay.
And so we've got our two chemicals or our two liquids that do not want to mix. And even if I tried to mix them up, they would separate again, which is really kind of cool.
Like you'd stir it and they'd still.
Yeah, I'll show you a little bit here. I'm gonna add, if I can get it out, some red food coloring into the top. Whoa. And how cool is that? You see those color droplets, they're not mixing with our oil. They sunk to the bottom, but they kind of hung out at that barrier. So I'm gonna put my lid on here. Okay. And I'm just gonna mix it up a little bit so you guys can see. Eventually we'll get those food color droplets out of our oil. Okay. We mix it up together, and now if I just let it sit, everything's gonna kind of settle down.
So some of that color that we're seeing, is that from the food coloring in the water, or what's happening?
Yeah, so once we mixed it up, that food coloring was able to get out of the oil and get down there to the water to then mix with the water.
Okay, okay.
So the longer I let it settle, the more it'll kind of calm down a little bit. So I'm gonna add, let's see, should I add some food coloring to this one too?
Yeah.
I'm gonna add my food coloring first in this one. If I can get it, my fingers are a little slippery now. So we've got our food coloring, mix it in there. I'm gonna be a little bit more careful when I pour this time. Thanks, Amanda.
Yep.
So we're pouring it in, and you're going to start to see, again, it's trying to mix initially, but eventually it will separate out, which is really cool. Because again, those molecules do not want to mix together. So we get that bit of a barrier, which is really nice. But then you also wonder, like, why is the water on the bottom and the oil's on the top in both times? And it is because of density. Right. Have you ever heard of density, Amanda?
Well, I mean, can you explain it? How does that work?
Yeah, so density is like, well, there's an equation. Density equals mass over volume. And it just is really talking about how tightly your molecules are packed. Oh. So I came up with this all on my own, and I really like it. Okay. So you guys are going to take one hand, and you're going to make this like weird claw shape, okay? And you're going to pretend that your fingers are the molecules. So you got this weird claw shape. Take your other finger, and you can kind of poke in between your fingers, right? There's lots of empty space. It's not very tightly packed, right?
Sure. Yeah.
Okay. Now take your hand and make a really tight fist, super tight. Now take your finger and try and poke, and you really can't get in there because your fist is so tightly packed. This is really dense. Those molecules are so tightly packed, really dense. This is not very dense. There's lots of space in between. So your really dense things sink to the bottom. And your less dense things are going to hang out on the top. So in this instance, our water is more dense, it sinks to the bottom. Our oil is less dense, so it floats on top.
That is so interesting.
Isn't that cool? You can do like density experiments at home by like testing, does it sink or does it float in the bathtub, in the sink, whatever. So here, now that this is kind of calmed down, you can see it's separated back out. Right. And so we need to get that lava lamp going. So I've got here some Alka-Seltzer tablets, all right? So I'm gonna take my Alka-Seltzer tablets, and they start out in these big kind of disc round shapes. I put them on the table for you guys to see. This one broke in half because apparently I was not very careful when I was handling the package. But that's okay because I don't think when it's in its full shape, it could fit through the top of our bottle. And so we're gonna do one of our lava lamps, and I'm just gonna keep it broken just like this, and we're gonna put it here, and I'll do the red one. So I'm gonna drop in 1, 2, and we're gonna see if anything starts to happen. Immediately we start to see bubbles, right? So you start to see bubbles forming, and then as those bubbles start going, they start to lift up some of that colored water and bring it up into our oil to give us a homemade lava lamp. If we wanna, you know, is it working?
Mm-hmm. Yeah.
Sweet. So is it still going? I can't see.
It is actually not still going.
So
it
it finished.
Your tablets came to the top.
Came to the top. So that went pretty quick. I'm going to take some Alka-Seltzer tablets and I'm going to increase our surface area. So that is all of like the area around your tablet.
Okay.
So before, like right now, our surface area is this side, this back side, and then everything around it, right? So if I take my tablet now, and it's just oil everywhere, and I start to kind of pound on it, break it apart, instead of just having those few sides before, now I've got 1, 2, 3, 4, 5 sides on this one. You know, so you're increasing how many sides you have on your tablet, which allows you to increase how many places it can react.
So you're increasing that surface area.
Increasing the surface area, and then you also increase your reaction and your reaction rate. All right, so I'm gonna go ahead and I'm gonna drop this in the green one. Mm-hmm. We good?
Yes. Yep, we can even back out a little bit further. There we go.
So we're getting it in there.
Perfect. Oh, yeah. That looks awesome.
Yeah, so now you can see a lot more is happening at a faster rate. And should we do the lights, Amanda?
Absolutely.
So I got another flashlight because apparently we are all about flashlights today. And if I put the flashlight underneath,
that's pretty.
Now you can see, yeah, our lava lamps in action. So this is really fun.
Go ahead and get really close on that because that is super neat.
Yeah, if you've got these materials at home, you can certainly do this. You can see our lava lamp is starting to calm down and quiet. So what do we need to do? We just need to then add more tablets to get that reaction going again. And that's our simple experiment today.
That's super cool.
Yeah.
So like as you add tablets, is it going to keep going like that?
Yeah, so it'll keep going. I mean, eventually you'll get to a point, I'm sure, where it's reacted enough. Sure. You know, it can't take anymore. Kind of like you made your right, this is a little crazy right now. You made your super saturated solution. Eventually, it wouldn't be able to react anymore.
Very cool.
Yeah.
All right, so what do we have coming up next? Do we know?
Ooh, that is a great question. Oh,
we do.
We do know.
All right, so next week we're going to be coming up to you guys. Again, we're going to keep doing our science content. And also, if there are things that you're interested in or want to see, certainly tell us because we love doing new science experiments and we'd love to hear from you. So next week we are going to do a program that we call Science of Magic. And these are some things that you're going to need. We're going to post this as well so you don't have to worry about reading through this too quick. But it should be super fun. And you're going to find out that science is pretty much behind every magic trick.
I cannot wait.
So next week, we're going to see you again, Kids Discover Online. Definitely try this at home. We'll see you later.
Bye.